To understand the concept of probability and how to calculate it, we often do problems involving a standard deck of cards. I don't want to assume that everyone is familiar with that, so I have a nice picture here that explains to you what a standard deck of 52 cards would look like. We have what we call 4 suits. Those are the hearts that are red, the clubs that are black, the diamonds that are red, and the spades that are black. So we have 2 red suits, 2 black suits. In each of these, we have 13 cards. We have an ace, which is kind of like a 1. It depends on how you're assigning the value. And then the numbers 2 through 10. And then what we have are picture cards, are also called face cards, jacks, queens, and kings. Okay, so I'm going to have that in the notes for you in case you need to refer back to it. Let's see if we can use that to calculate some probabilities. Got a little bit smaller image there so we don't have to flip back and forth. So we are dealt 1 card from a standard 52 card deck. Find the probability that we get an ace. So probability is the number of favorable outcomes that we want in our event divided by the total number of outcomes. Well, this graphic here is our sample space. There are 52 different outcomes, so that's the denominator. What about getting an ace? Well, I see there is 1 in each suit, so my probability here would be 4 out of 52, which we reduce to 1/13. Okay, if I wanted to, I could change that to a decimal percent, but I'm just going to leave it as a fraction. Okay, if that makes sense to you, go ahead and see if you can do the next one. What is the probability that you get a red face card or picture card? All right, well, we have 2 suits that involve red cards, the hearts and the diamonds, and I have 3 face cards in each of those, so 6 out of 52 or 326 is the probability of getting a red face card. Last one. What is the probability you get an even numbered spade? Okay, so the spades is this bottom one, and the even numbers are 2, 4, 6, 8, and 10. We're not going to assign a value to the face cards, so that would be 5 out of 52, which we cannot reduce. Let me know if you have questions.